How do you use the luminance layer in astrophotography? Imagine capturing the universe in all its intricate detail and then making it even clearer. That's what the luminance layer does in astrophotography. It's like the foundation of a beautiful painting, providing the sharpness and contrast that make celestial objects stand out. When you take astrophotos, you often shoot through different filters or cameras. The luminance layer is usually a black and white image that records the brightness of everything in your shot. It doesn't include color, just the light intensity, which is what our eyes see as detail and contrast. This layer is made with a monochrome camera or a special luminance filter that lets a broad range of wavelengths pass through. The reason it's so important is because the human perceives most fine detail through brightness rather than color. When you combine the luminance layer with the color data, which comes from red, green, and blue channels, you get a final image that's both detailed and colorful. This process is called LRGB imaging. To get a good luminance layer, you can either take real luminance images by capturing multiple long exposures with a luminance filter or monochrome camera. These images are usually taken over several nights to gather enough light and detail. Alternatively, you can create a synthetic luminance by combining the red, green, and blue channels from a color image. This method is quicker but might not be as detailed as real luminance. When processing your luminance layer, start by cropping out the edges that have low signal or noise. Next, remove any background gradients caused by light pollution or optical vignetting. Then, boost the contrast and sharpness to bring out faint details like distant galaxies or nebulae. For objects like emission nebulae, using narrowband filters such as hydrogen alpha can help create a luminance layer that captures specific wavelengths, revealing more detail even in areas with light pollution. In practice, capturing the luminance layer involves longer exposures or multiple shorter exposures stacked together. This helps build a high-quality image with lots of detail. You might spend several nights gathering data, then combine it with shorter exposures of color data to produce your final astrophotos. For those involved in astronomy outreach or research, understanding the importance of the luminance layer shows why investing in good equipment like monochrome cameras and filters makes a big difference. These tools improve the clarity and resolution of your images, making them better for sharing or scientific analysis. Overall, the luminance layer is the backbone of detailed astrophotography. It provides the sharpness and contrast that make your images pop. Properly capturing and processing this layer, then combining it with color data, results in stunning images that reveal the universe's hidden structures and beauty.